systems, hacking panic button systems. I know with everything going on in this apocalypse, there are lots of reasons to panic, but as we're about to show you guys, these systems aren't going to help you in any way with that.
So, hey everyone, my name is Amanda Brown. I'm a rising senior at RIT, and I currently work as a co-op for IBM's X-Force Red as a pen tester. For this research, I primarily focused on the networking, reversing, and anything within the Windows domain.
Hi everyone, my name is Hannah Robbins, and I am about to start as a pen tester full-time with X-Force Red. I just finished up getting my undergrad at the University of Tulsa. For this research, I focused primarily on anything in the mobile application world, stuff including testing of our Android and iOS apps. And then I also worked with all the web testing in the wild web.
So before we dive in, let's talk about panic buttons in general, since it's a little bit niche. The best way to explain it to you guys is to have you think about a classic bank robbery scene in a movie. So the robber will come in and demand the teller to give them money. And then the camera pans to the teller who hits a button underneath the table. That button is a panic button, which is essentially a way of announcing an emergency to either the police or some pre-assigned contacts. Panic buttons can be in the form of a physical button, a mobile application, or some sort of software.
So you might be wondering, why should we care about all the vulnerabilities that we found in panic button systems? Well, first off, panic button systems aren't industry specific. They're used as often in the government as they are in education, as they are in banks, as they are in local small businesses. In addition, panic buttons are used by individuals. So some of the products that we tested could be used for individuals wanting to make sure they got home safe from a concert, or individuals that are older that want to be able to live their lifestyle, but recognize that some things might happen. In addition, the panic button systems that we tested aren't just United States-based products. These are used by people all over the world. So when we found all these vulnerabilities, it's not just one person, it's not just one industry, but it's everyone that's affected.
To give you guys a little background information, Hannah and I both worked as interns for XFR last summer. One aspect to our internship was completing a research project within a month and a half. And we decided on testing a span of panic button systems, primarily focusing on 3 different goals for our research. The first being to suppress a panic alert, meaning a user has triggered that alert and they believe that it's valid, but we've actually suppressed that transmission. The second research goal was to start a panic alert without that valid user interaction. And finally, we wanted to stop an active panic alert.
So before we go on to the bulk of our presentation, just want to give you a little bit of an overview of what you're going to see. First off, we're going to go through the 3 products we tested: Silent Beacon, Little Green Button, and Community Response Systems. We're going to present all of our vulnerabilities as viable attack chains, putting together all the vulnerabilities to go from low to no knowledge to be able to completely render the product or some of the other things associated with it useless. Just a disclaimer before we start, we're going to be using some examples of some real world companies. We have no knowledge at all if any of these companies use this product. We're just using them as stand-ins so you guys have an idea of the attack scenario. We also aren't advocating using these vulnerabilities to attack anyone. We want to make sure that these products are more secure after the research we've done.
So now that we've covered our butts, the first company we'll be discussing is Silent Beacon. They are a United States-based product with worldwide clientele, primarily focusing on the individual safety. Between the App Store and Google Play, they have approximately 100,000 downloads, just so you can get a gauge for the impact.
So let's talk a little bit about how Silent Beacon works. Silent Beacon is primarily a mobile application. They have Android and iOS versions. When you first get to this app, you go ahead, you register, it gives you an account that's associated with your phone number. You can go in, you can customize everything from which contacts are texted, an alert that has a map that has where you were when this panic alert started to where you are when it stopped. And then you can also integrate with a physical Bluetooth panic button. However, we did not do any testing of that physical button. Important things to note with this product: the only way to stop an active panic alert once you start it is to enter a PIN number, and then everything's good. It's as if there was no panic alert. You're fine now.
So, as we mentioned beforehand, we want to have a little bit of fun with these vulnerabilities and present a valid attack chain for you guys. So, bear with us. Let's say that Hannah and I can actually leave the house and sit down at our local Starbucks, 6 feet apart from others, of course. And as we sip our coffees, you know, we're on the public network and we're people watching through the packets. And we stumble upon an interesting HTTP GET request that begins with tracker, as you guys can see on the screen. Now, Hannah and I are curious individuals, so naturally we're going to go to the link, we're going to check it out, and we see a map with a person's name on it, and also 2 different pins. One pin where their panic alert started, and the other pin where their panic alert ended. Let's say that I leave my house and I notice someone is following me. So I'm going to set off my panic button. I'm going to set off that alert and walk to a nearby location where I feel safe. As an attacker, Hannah would now know where I live and a place where I obviously feel safe at. The implications of being able to know the exact path that someone would take when they feel panicked is frankly alarming.
So we're still at Starbucks, we are sipping our coffees, and we happen across this GET request here. We examine a bit, we recognize that what's happening here is a login of a user. There are several different ways to log in to Silent Beacon, but the first one is to give them your phone number, and then they'll call you and they'll tell you, here's your passcode, now you can log in. They're trying to make sure that you actually have access to the phone number that this account's associated with. However, you actually don't need to be able to log in. As you can see here, this is an HTTP request, and that password that we're wondering about is just in the URL. So we use burp with intercept on. We go ahead and try to log in, and we stop that request. And now we know that that passcode that would have been called. However, the actual user of that product, whoever has that specific JID you see, didn't actually get that call and doesn't know that we're now successfully logged in to their account. So now that we're logged in, there's a lot of stuff we can do. We can go through and change the contacts that are going to get information when there's a panic alert. We can also go ahead and do some things like changing the name. And when we did that, we saw this post request here that has the method update user details. And what we realized here is that all we needed to update a lot of user information is just have the correct phone number, which we already got because we logged in. And the important thing to focus on here is that you can change the PIN number. Since we wouldn't need to know the PIN number to log in, but we do need to know the PIN number to stop a panic alert or to log out. We need to make sure that that's something we know so we can continue to test this product without having any sort of issues. So we can go ahead and just use the same method to change the PIN to whatever we want. And now we can go on with our testing. So now comes the fun part. We actually get to messing around with the testing of the panic button functionality. And as we were doing this, we recognized that this HTTP request that you see here actually has the information that is sent in text messages to any of the contacts that are associated with your user's panic alert. So say I'm one of Amanda's contacts and she had that panic alert we were talking about earlier, I would get this text that says she needs help and access to that tracker website that you can see all that specific information on. Now, since we've already went ahead in our account that we've been playing with and we've changed all the contacts so it doesn't matter, and we're logged into this user's account and we've intercepted this message, now that's where the fun comes in. We can go back, we can change everything back, we can change the PIN number back, we can change all the contacts back and get out of there as if nothing had ever happened. But here's where the fun comes in, because there's actually no replay protection against sending this message again. So now a week later, say we could send this message that this person needs help, but they don't because it's an old message and nothing's actually going on. So the user's contacts, the people that are supposed to make sure that the user is okay if something happens that causes a panic alert, realizes that there was nothing wrong. We do this enough time, we will make sure that the user doesn't actually have any trust with this product, and that any contacts will ignore an alert that happens if there's something that's actually wrong, creating a scenario where it's like the user's crying wolf and none of the contacts want to help them anymore. But that's not the only thing we can do with this product.
So we've been playing around, we've had a lot of fun, but coffee's getting cold, it's time to move on. There's one thing left to do though, and that's delete some accounts. We established before that we have the ability to make people completely lose faith in this product. So why not just do them a favor and delete their account? All we have to do is call the method delete user, providing their phone number as the parameter. So this is the result of calling the delete user method from a simple GET request. Your information is cleared, including your name and your password. Any account that is deleted in this way can't log out, and they can't silence any alerts that they create. Instead, they'll receive the pop-up of user does not exist. And with this, pretty concerning, especially when you keep in mind that the only information we needed to delete this account was the user's phone number, which in the grand scheme of things isn't that hard to find. If we really wanted to mess with things too, we could simply script the process of iterating over every single phone number, ensuring that no one is safe and no one can rely on this product.
So now it's time to talk about Little Green Button. Little Green Button is a United Kingdom-based product with worldwide clientele with a slight healthcare focus. They have approximately 50,000 users, and some of the biggest companies that use their product are Mercedes-Benz, Yum, and the United Kingdom's National Health Service.
Out of all the companies that we ended up testing, Little Green Button had the most complicated setup. When you install the software, multiple Windows applications were installed, but you wouldn't use most of them. They also have an Android application and an optional physical button. We did not test the physical button, just for full disclosure. And in order to configure and activate your account, you would go to the management portal. Once everything was set up, then you would have that green button in the corner of your screen, which is a shortcut link to the application. In order to create an alert, all you would have to do is double click on that green button. Once an alert was made, your fellow Little Green Button users would receive that pop-up alert saying assistance is required by user.
So now it's time to get into a hypothetical example. So we're going to say in this case as a placeholder, McDonald's. So say I'm really invested in finding out why McDonald's fries are so fabulous. And I happen to look across some of their computers and I see that telltale green button because you can't really hide it. It has to stay on screen at all times. So the first thing that we want to find with this company is how to get access to their management website, how to figure out what their configurations look like and everything like that. We've known, because we've done a little bit of testing, that all you need to get to a specific account's management website is this 14-character key. However, as you can see from the picture here, even though these 4 different sites were made at 4 separate times with separate information, 8 of the 14 characters are the same. Now, it goes from being very difficult to figure out what this key would be to only having to brute force those 6 uppercase and lowercase letters. Now, this still does take a decent amount of time, about a little bit more than a little bit less than 2.5 billion tries. But one attacker with one laptop going through these could find every single key in a year and a half. Say I enlist Amanda in this and her 4 laptops. And now it's kind of trivial to figure out all these different keys. And if we get lucky, we'll find McDonald's key pretty early. Now that we've found McDonald's key and we have access to what will be their management site, now we get to have a little bit of fun. As you can see here, we're going to be logging in to what's our demo Little Green Button management site account. We made some different accounts to test things to make sure, okay, we know how this works. Now this is going to be, in this case, our examples, McDonald's account. They haven't actually done a lot of things. They actually haven't requested their password. So hypothetically, we shouldn't be able to log in or do anything with them. Now we're going back to our demo account that we've made. We know all the credentials for, we know the password and everything. And we're going to go ahead and log into that. So now all of those previously grayed out things are green and we can do anything with our configuration. But what we care about is going back to McDonald's. And now, as you can see, all you have to do is refresh that page. Now we have full access to McDonald's site without having to know their password. It even still says we're logged in as our user for our demo account, but we still have access to change the configuration information without ever needing a password.
All right, so keep in mind that up to this point, we know with confidence that McDonald's is using Little Green Button, and we even know what their site ID is. Naturally, as the attackers, Hannah and I are going to do some recon on the product. This might include us creating a fake account like you saw in the demo. We're going to use this fake account to map out the website and monitor the normal functionality. Doing so would lead us to see multiple requests to config.littlegreenbutton.com along with our site ID. So let's check it out. All right, so here's our file. As you can see, it includes all of our network information, what port Little Green Button is hosted on, and a bunch of personal information. Every location you have configured is shown along with your group ID, the name, coordinates, and telephone numbers. Keep in mind that this is for every single location that's associated with your account. So if we found the configuration site specific to McDonald's, we would have every single location that uses Little Green Button along with employee information and network information. And even worse, as you guys can see, we have a directory list that contains all previous versions of our site configuration as well. So not only do we have the current employee information, but we have information on all of the employees to ever work there. And so up to this point, we've done recon on the website side, but what about the Windows software? If we're targeting a company where employees will most likely not have company phones, investigating the software that would be available on Windows makes sense. Similar to all the web stuff, we need to understand the application and get that normal functionality. So for this, I typically use Procon as one of my key tools. And as I mentioned earlier, Little Green Button is decently complex. And they installed multiple executables onto our system, all of which made the mistake of referencing DLLs that did not exist. So we know that it's missing some stuff. What can we do? Well, we can generate our own DLL, or we can create our own. It's however you want to do it. There are tools like Metasploit that you can use to make the process smoother. So we've made the DLL. Now we have to get it onto the victim's system in order for this to work. And for this, we're in a pretty unique situation where we have a lot of information on the employees from the configuration files. So if we use that information, we kind of have the golden ticket for a phishing attack. Let's assume that we were successful and the poor employee downloads our DLL. And next time that they start up Little Green Button, our DLL is successfully loaded in. Now, depending on the attacker's intentions, a lot can be done here. The first time we tested this, we used Metasploit and started reverse TCP handlers, and we got an alarming amount of reverse shells onto the box. In fact, this DLL ended up being referenced so many times that it froze the application, rendering them completely useless. Once the DLL is loaded, a person can't trigger any panic alerts. They can't silence any alerts. In fact, they can't even view the application. So that's bad, right? We were essentially handed a loaded gun by having access to the company's configuration file.
Now, we went back to config.littlegreenbutton.com, which is an HTTP website, and we realized that it's not just that one configuration file, that folder we found, but it's every single configuration folder for every single company that's using Little Green Button is publicly available on an HTTP website with no authentication.
Yeah, and keep in mind that within each of these folders, you're going to have information on every single location, every single employee. Imagine if you have your CEO's location in. That's not good. But I mean, this is kind of like the Grubhub of config files, you know?
You can choose a lot of different options here to exploit with those vulnerabilities we talked about earlier.
So we've accomplished our goals for Little Green Button. So time to move on to our final company, which is Community Response Systems, or CRS. They are a United States-based product with North American clientele. They are used by hundreds of companies, primarily in government and education. So a couple examples are ThinkGuard and the Indiana Wesleyan University.
So CRS works a little bit different than some of the other products we tested. CRS actually has a local server. So one of the computers in your company actually has to be the server location. And from there, all the other clients will connect to that. And each of those clients is called CRS Notify. And you can see those on the bottom right. With CRS, you have separate options for a low panic alert or a high panic alert, depending on what the scenario is. And with each one of those, you can see a lot of information about it from that CRS Notify application, including who started it, what the location is, and what time. And then you can also reply to that and give more information or say what's going on. However, the only place you can actually stop a panic alert for CRS is using their management portal website. So you actually have to log into that to be able to stop any panic alert that's going on. And you can also use that to configure additional users and to adjust different settings. Worth noting here, CRS also had physical panic buttons. We were not able to test those for this research.
All right, so up to this point, it's been a proper day trip for Hannah and I. We had some coffee at Starbucks, deleted some accounts, went to McDonald's, ate chicken nuggets, rendered an application entirely useless. But this next one means a lot to us. We've been thinking about the next company for a little while, Home Depot. Now, we knew that Home Depot would be using a panic button. So at first we try little green button because we already know a viable attack method for them, but no dice, doesn't work. So we move on to our next contender, CRS. We happen to know this little problem with CRS called user enumeration. As you can see in the slides, CRS will give us a different URL when we try to give an invalid username versus when we give a valid username and an incorrect password. So we can leverage this to find out if Home Depot is using CRS or not, just by looking at the URLs that we're receiving back. And what do you know? They are.
So we decide in this fictional scenario to continue to go after Home Depot. And since we know a valid email that is associated with someone using this product, we decide to fish them and see if they happen to have this email that every user, when they start setting up their account for this product, do they get an email similar to this with their username and their password in plain text, just hanging out in an email, and also telling you conveniently where you can go ahead to log into your management portal. We were hoping in this fictional scenario, we were hoping that maybe Home Depot would just keep their credentials the same, and we wouldn't have to do anything. We would just be able to log in with the creds we found here. However, unfortunately, say that's not the case. Say we don't have any luck on this front, and we have to turn to something else to be able to get credentials to log into their management portal. That's where intercepting traffic comes in. The next way that you could possibly get credentials is if a low privilege user tries to change their password. When a low privilege user changes their password, all the information that they're changing goes in the URL. So if they are just changing their password from lowercase password to uppercase password, and we happen to intercept that as it happens, congratulations, now we know the email and password associated with their CRS Notify account. We also happen to know some information about them, full names, those kind of things. So now we have a lot more information and can leverage this against, in this case, Home Depot. But maybe that's not the case. There are some other inherent flaws with this product that could allow us to get credentials. What you see right here is our CRS Notify application. So we're going to look at it here. We have a lot of information there, and you have that little logged in as thing that you can click on. And when you go ahead and click on logged in as, it goes ahead and it simply logs you in to your CRS Notify the CRS dashboard. And this is very useful in the case of trying to stop a panic alert. You press the button, congratulations, now you can go ahead and stop it. However, when you do that, it goes ahead and sends a GET request that has your username and password in the URL. So if anyone tries to log into their Notify account that way, now we have access to their credentials. But maybe we haven't had any luck, and that's where Amanda comes in.
All right, so as Hannah mentioned, we haven't had any luck with using those means to get credentials. So we're going to use a unique experience that we've had with Home Depot, fictional of course, where every time we go in, there's always at least one computer that is unlocked and unmanned. We know this from our obviously extensive background in going to Home Depot. So we decided to scope it out. We want to see more about their usage of CRS. But we get onto the computer, just a normal guest account. No fun, right? Well, CRS actually stores the username, password, and server IP for their server component of the software within the local machine hive of the registry. So now we have valid credentials on a guest account that has never even touched CRS. But what if we want more? What if we think that there are potentially more users? Now we start digging around. Within the app data in the local directory, there are files called user for both CRS server and CRS notify. And in both of these, the username and password are stored, and then in the CRS server, the server IP is also stored. So this would potentially give us one more set of credentials to log into an employee's account, or even worse.
So if you're keeping track, that brings us to up to 5 separate ways that we could get credentials to log in to CRS for this company. First one, if they just didn't change the password from the one that was given from them in the registration email. Next, if a low privilege user happens to change their password. Third, if someone clicks on their name in the CRS Notify application. Fourth, by looking at the registry on a local account. Or fifth, in a file on a local machine. And this is important because whenever you log in to CRS Notify, the server sends you a bunch of information. This information, as you can see below, is completely unencrypted. All this information is sent in plain text, includes location ID, the name of the company, address of the company, phone number associated with it. You have your admin, user emails, if anyone's getting text alerts from any sort of panic alert that's going on. And then you also have, for each of the users, their information, their hashed version of their password, and also any phone numbers or location information that's associated with them. If we were invested and we had a lot of time, we could go through and we could try to figure out what those passwords were. However, since we've already found those, and that's not necessary for some of the fun that we're about to have. So let's get down to it. With the panic button system, we always were trying to figure out with each of them, how does a panic alert work? And with CRS, as we've mentioned, you go to the management portal, you click, you go there, and in this case, as you can see on the top, there's that end alert button. So we press that button. Easy enough. Congratulations, now we've ended an alert. We found out really quickly that all it is just visiting that URL, and that's all you have to do to end a low or a high level alert, as you can see from this request there. But how does this tie back to our attack on, hypothetically, Home Depot?
All right, so as you guys saw in the last slide, in order to stop that panic alert, you just have to go to that URL where you're identified by the parameter loc ID, also known as your location ID. Each location ID is associated with a specific account. So the URL that's used to stop any panic alert is the same every single time except for your location ID. There is no login or authentication required involved in this process. So you have the ability to stop any alert that is happening just by providing a 4-number identifier. Going back to Home Depot, we've established that we know they're using CRS, and just by sniffing their traffic or through one of our other means, we have their location ID. If I were to go into Home Depot and start making a big scene about paint, they gave us the wrong paint color, I'm very upset, and I try to steal a bunch of paint buckets, the natural assumption is that they would raise a panic alert. However, just by going to one URL, Hannah can ensure that those security guards don't come running for me when I walk out with the stolen goods. It's a relatively silly example, but the implications are there. There are way more serious situations where people are using these devices, these products, but with a series of flaws as this, they aren't reliable. Keep all that in mind as we show you how simple it actually is.
Okay, so as you see here again, we have our CRS notify product, and we're going to go ahead and create a high alert. As you can see, that alert state changes to high, and now we're going to go ahead and we're going to do something super simple. We're going to go ahead and put that URL right there, and we're going to go ahead and go to it. As you can see here, this loc ID is a specific loc ID that we've been trying to attack. Now we go to that website, and as you can see on the CRS Notify application, that alert state is back to inactive. Nothing happened. And we weren't even logged in. It prompts us here to log in. So it's pretty simple as long as you know the loc ID to stop any sort of active panic alert. But let's take a step back on this one, because CRS is the product that actually needs the least amount of information to be able to utilize it and to break it. Because say we didn't find out what Hobby Lobby or Home Depot's loc ID is, and instead we have no clue, but we saw that they're using the product and we want to do some sort of attack, something serious. All we'd have to do is go through and script to go ahead and toggle with every single loc ID, starting at the lowest number and going to however high we think they might be. And we would stop any active alert without having to know any information, just knowing they have CRS, we can get around this. It's pretty simple, and it's pretty concerning that a product like this is this easy to circumvent the entire goal of the product.
All right, so hopefully you guys get the vibe that there are a lot of problems with these products. As a note, we did responsibly disclose to the respective companies, but even just with our findings, we barely scratched the surface of this untested industry. We had a very limited amount of time to complete our research, and we only tested 3 different products. And even just with that, what we found was alarming.
We took you through a bunch of fictional scenarios. None of the companies that we mentioned at any point that in our attack scenarios we know are using any panic button product. But we showed you that there are critical cybersecurity issues and products that are intended to keep people safe. The very thing that's supposed to help them is actually opening them up to a wider attack surface. Silent Beacon, now we could get, we could delete all these accounts. We can create a panic apocalypse with little green button. We now know all this information about every company that's using little green button, all that configuration information with no authentication whatsoever. And we have the ability to get a reverse shell on any computer that's using little green button. Then we come to CRS, where now we can stop any sort of active panic alert for any product without having to know any information except for that specific URL. These products were not made with security in mind, just in the thought of we can make a panic product, we can try to keep people safe. But by trying to add more safety, they're actually just opening themselves up to greater risk. And that's really unfortunate, especially because this is just one test of 3 of the panic button products. There are so many other items in the panic button industry, so many other systems that we have not tested that are probably just as insecure as this. Any questions? And could we get those questions in chat? I don't have a, would that be possible? I don't know if there are.